G'day, I'm Glenn Morris from the Smart Energy Lab, and today I'm here with Steve Davis from Delta. Now, Steve, you came all the way from Sydney to see me.
Yes, of course. I've been looking forward to it, actually.
How was the trip?
It was a long trip, Glenn, but it's nice. It's lovely out here in the country. It's a glorious office here.
And you tried to get an electric car to come up and...
Yeah. I don't want to name names, but there's one car company that we won't be bothering using again, I can tell you. But... yeah, so quite the reverse. I've now got a big four-wheel drive that rolls around and not quite the green feel that I wanted to present with. But
well, if you'd come up in an electric car, you could have plugged into the Delta 50 kilowatt DC charger.
Yeah, that's right. You've got some gear out there. My goodness, there's a lot of good stuff.
Yeah. I mean, just talking about electric vehicles for a moment, it's been amazing how quickly the transition here on the co-op has happened. We're an off-grid community, as you know, so we've got no grid power here. And, personally, I never thought we'd ever be able to run electric vehicles because of the limitation of, how small inverters used to be. But these days, inverter power's gone up, solar power's become very affordable, and now we've got, high-powered chargers available, and everyone's the next purchase seems to be an electric car.
Well, that's right. Now the governments have to stump up and how they're going to support provide the grid that's going to be able to support all this growth in the renewable and electric vehicle chargers. Yeah.
Well, I think that's where solar at home comes to the rescue, and probably storage as well, because not everyone's got their car at home during the day.
Well, it's a good combination of those technologies available now, and that's only developing.
Yeah.
I think the industry's probably a few steps ahead of where the government needs to be, really, with providing the infrastructure. We're seeing a lot of that in some of the rural areas too. Electric vehicles still have limited coverage.
Yeah.
And of course, putting in a 50 kilowatt charger in a remote outback place is just probably not just not really suitable for the grid that's available out there. So seeing battery energy storage now coupled with electric vehicle chargers, sort of solving that problem.
Yeah, so where capacity-constrained networks can use batteries to meet those intermittent peak loads, like charging a car, and then trickle charge the battery back up over some hours.
Yeah.
And it's certainly what we can do here too. We basically can charge when the sun shines.
Well, you've got a lot of solar out there, haven't you?
Yeah. It's been good. Hey, Steve, so what's your role at Delta?
So I'm the sales director. Delta's made up of a number of different business units. I look after a couple of those business units, one being the LTEC brand, so, from telecommunications, industry, and then the Delta brand for UPSs for my sins as well. So the residential off-grid system falls into that area. That's one of the LTEC brands. So that's fits within my scope. So
really Delta's a system integrator with their products from various suppliers. So you've got LTEC, which is part of the Delta family. You've got batteries. I noticed we've got Polarium, right? Yeah. Are they part of the Delta family or they're the third party?
A third party, but I wouldn't say we're a systems integrator per se.
Yep.
We're certainly a power electronics manufacturer,
yes.
a global power electronics manufacturer. And we have what we say, we have many brands, one company. So Energy's another brand of product we supply, Vivatech for security systems and so on, and they're 100% owned by Delta. The LTEC brand has been around for 50 years. In fact, in Australia, for 27 years. And
wow.
And my history actually is from the LTEC side of the business. And but Delta acquired us in 2015. Just gave us a lot more widgets and a lot more things to sell.
Yeah.
And the LTEC brand continues on today and will continue on.
So we're here today really to talk a bit about this product, this Rural Electrification System or Solutions?
Well, I don't know who came up with that name, actually. It's a mouthful, isn't it?
It is a bit of a mouthful.
But primarily it's an off-grid energy storage system, with multiple energy inputs, whether that be solar, battery, or potentially a diesel generator too.
Yeah. Cheekily, I call it a power station because it basically is everything you need to...
Power station.
Yeah. I call it the Delta Power Station.
You haven't patented that, have
No,
you?
not yet.
Can we use it?
I mean, the term gets thrown around a lot, but, it really is an all-in-one power station, right?
Correct.
So we've got products like these, which are the solar chargers, which are modular, and we've got the rectiverters, which are rectifier inverter modules.
Correct.
All of that in a big cabinet, which you're going to look at in a minute.
Yeah.
But a little bit about the history. So where did, say, rectiverters, what was their first application?
Well, actually, its first application was in the marine industry, where typically what we were seeing was, on ships, you've got a closed-loop electrical infrastructure.
Yeah.
You typically had a UPS, which providing AC, and then there might be some DC applications as well. And they were using a lot of space. And in Norway, where with the original R&D teams for these products, were approached by the shipping companies there, and they said, wouldn't it be great if we could combine, AC and DC and a static switch into one box? And the engineers thought it was a great idea. And a few years later, the rectiverter emerged. So we have, AC and DC on the output. And there's a couple of different varieties now with either 380 volt or 480 volt, 48 volt.
So these come in different voltage ranges.
Correct, yeah.
Right, 48, 110 and
110 and 380.
Yeah, right. So depending the application. I mean, frankly, this is so small. I can remember installing, inverters of similar power rating, which, took nearly 2 people to lift to put on the wall. And now we've got these tiny little units which just plug in at the back here. So you've just got a back plane that these all plug into?
Correct.
Yep.
Yeah, so, hot swap, load sharing too, of course. When we have a look at the system later on, we'll see a number of these across different power racks. And the good thing about it is, of course, is that if there is a failure for some reason or another, which is very rare, I will say, but you just pop it out.
So when you say load sharing, if you've got more than one, they proportionally share that whole load across the multiples?
Correct.
Right, so effectively they're running very low, very lightly most of the time.
Most of the time, that's right. I mean, there's obviously a peak, a nice sweet spot where you're getting the maximum efficiency out of the power conversion.
Yes.
But the good thing there, though, is if you do lose one, you don't have, your load is still maintained because, typically you'll have redundancy built into the modules.
Yeah.
So you're not going to drop the load. In other types of inverter systems, if the inverter fails, then you drop the load.
Right.
Whereas what we're seeing here is a very high level of availability, support for the systems.
I guess that's part of its heritage coming from the telco space, which is the 5.9 reliability.
Correct.
It took me a while to learn that one, 99.999% uptime.
Well, we're pushing that out now to 7 and 9 nines in some instances.
Right,
yeah,
okay.
So, obviously you could have two systems in parallel, so you've got an N plus N arrangement and redundancy built into the system, but that all depend on the critical nature of the load, the equipment that you're supporting.
Now that you're moving this product from, say, the telco space into the off-grid space with the res unit, the Delta Power Station as I call it, that reliability really does make sense because off-grid, and I often have to explain this to my students, is you're now providing critical power system for a home. You can't consider it as a feel-good thing. It's going to save you money. It actually runs everything. And if it stops working, they're going to call you on Christmas Day.
Well, that's right, and the whole idea behind this system, but this is not a new system for us. We've been providing off-grid power systems in the telco and mining industries for many, many, many years. We would have hundreds, if not 1,000 systems in Australia and the South Pacific, historically at 48 volt or at 110 volt perhaps, but exactly the same sort of topology. So all we've done here is really take a traditional off-grid power system that we've been supplying for many, many years and just change the output from DC to AC.
Now, can these units be used on-grid?
No, not per se. We are looking at a collaboration to have a grid tie inverter. But today, no. This is primarily an off-grid power system.
Right. So its alternative inputs would be a generator. Can it control that generator?
Certainly, yeah. The control functionality, in fact, we call it the Smart Pack. It's a pretty cool unit, actually, because that's the brains of the system. So it controls multiple inputs For example, we could have solar as the primary energy source, say the batteries as the second energy source, and then the generator, perhaps, if there's one on site, as the third energy source. And we would determine that by certain configurations that we would set up in the system prior to being delivered.
So once again, reliability. So you've got solar, which you could say is intermittent, it's daytime only, battery storage to supplement when there's no solar, and if either of those two aren't working because it's nighttime and the battery's discharged, and the generator can come to the rescue.
That's right.
Yeah,
that's right. Or if, heaven forbid, you've got a wonderful like a weather like we've got here, where the sun's shining and the battery's only required late at night, but you wanted to check that generator turns on, then we can also set it up so the generator turns on intermittently.
Right.
Yeah.
Now, if the loads are very high, can it switch to another source? Can it switch to generator only? So
sure.
You can do pass-through?
Sure.
Right. So you might have a case where there is one or two loads that are intermittent, very rarely used. Let's say you've got a big arc welder and a big pump, and they only run occasionally. So the demand goes beyond the continuous or the peak rating of these. That switching, is that instant? Or
automatically, yeah.
Automatic?
Yeah.
Okay.
Milliseconds.
Will it preempt by starting the generator?
Correct.
All right. So it sees the load rising, starts the generator, brings the generator on to supply that peak demand, and then when it's not required, it turns it off.
Correct.
Oh, wow.
It's all managed through the smart pack controller.
Yeah.
So, and we'll see it a little bit later on, of course, but it's a pretty functional sort of system. You don't need to be a rocket scientist or an engineer to drive the system. And again, all those parameters are preset. So when the system arrives on site, it's all in one box. It's just a few hours of connecting the AC in and the load's out. Turn it on and...
I don't know if it's even a few hours. So my installer, he just couldn't believe how easy it was. Like, he was in and out of the cabinet in about 25 minutes.
and did he charge you appropriately?
What took the time was running the cables back to the switchboard. So the usual bit you can't avoid, you've got to do some cabling, right? So, and my house is a bit tricky, going through straw bale walls and trying to fix to things.
Well, that's a good output. That's good.
But yeah, so the work with inside the cabinet was extremely minimal because it's completely built in a factory.
Yeah.
To a specification and tested.
Well, look, we have set up three sort of standard models.
Yep.
And we call it, grow as you go. So, the AC output or the rectiverter modules, can be added as you go along. The same with the solar converters, can be added as you go along. So you might start out low and then sort of build your capacity. If what you're looking for doesn't fit within those three models, then we can sit down with our engineers and work out, well, what is it exactly you do need and engineer the solution. I mean, that's a good thing, I suppose, with our organisation is we are a solutions provider across a number of different industries, particularly in the telco and data centre space. So our engineers are quite good at coming up with customer-specific solutions.
So we'll see this in a minute. We go and look at the unit, but you basically have shelves that will take up to 4 of these rectiverters per shelf, and each shelf can be a phase. You can have single phase, split phase, 3-phase.
Correct.
But you don't have to fill the whole shelf up. So you might actually just put, as we've got 9 units in there, then the customer comes back to you and a year later on saying demand's increased. We've put in some electric cooking. We're moving off gas. Those extra slots can be filled. Yeah,
very easily. Just buy the module, put it in the slot, hit the reset button because there's an asset register within the controller as well. So by populating the each slot and hitting the reset, what it does is it updates the asset register, so it'll see the serial number of the system.
Yep.
And it enters that into the controller. The controller memory, and also the date that it was installed as well. So you've got a good record of when the warranty started, and the serial number of the system.
Now,
of the module.
We'll move on to the solar control in a minute, but just in terms of the raw numbers on the front of this unit, so this is the nominal 48 volt unit,
nominal 48,
right?
Yeah.
So it can be used with lithium batteries, which it is in our case, which 54 volt lithium. It's got a 1500 VA rating with power factor correction, 1200 watts of continuous power, which is pretty cool. I noticed that it had a 32 amp surge rating.
Yeah.
So if you've got a trip protection, for instance, I mean, it is starting to become a consideration with off-grid is that you don't have the grid to trip your protection devices. I often call the grid an unlimited supply.
Yeah.
You know, when it wants to trip something, it will. This thing can actually trip a massively bigger breaker than its continuous rating.
Yeah, it's a requirement certainly within the telco and industry markets, and that's what it's designed to do.
And it will charge a battery from an AC source as well at 1,200 watts.
Yeah,
Per unit.
correct.
So once again, it's all about scalability.
Yeah, and within the controller as well, we can sort of manage that, what that charge current looks like to the battery, how fast you want to charge the battery depending on that particular charge current. So, and that's sort of a consideration. Yeah.
Now, only today I found out about a new function by looking at the software on my laptop that you've got smart charging as an option.
Yeah, smart power is well, it's a new thing, isn't it? I suppose this comes from industry where there's a lot of power systems out there in the market where there's batteries that are basically sitting around waiting to be used. They call it a lazy asset that's depreciating and not being used as often, and we're also seeing high energy costs. So it's a pretty good function if you can either identify that, hey, you've used up your allocation of energy, you're about to go into a peak rate period, and if you've got the battery resources available, we'll take the system off the grid and run it on battery for a while until a certain point, a predetermined point, and turn it back on. And this might be charging the batteries in an off-peak period, using the batteries in an on-peak period. In some other instances, there might be other elements where it might be demand response, where the electricity company says, well, hang on, we'd like to use your battery reserve. We'd like to give a big burst of energy on the grid, maybe straighten up the frequency, and we're going to pay you for that. Now, we use another product, a third-party product that actually will connect to the grid to allow us to do that. But that functionality, that smart power functionality, is actually built into the controller, and for a small license fee, we'll turn it on.
Right, so you can offer services to the grid.
Correct.
Wow. I mean, I guess when I said earlier on, can it be connected to the grid, you answered in the sense that it's not grid interactive without a third-party product.
Correct.
But it can be connected to the grid as a charging device.
Correct.
And that means it can do things like absorb too much energy from the grid by charging batteries and be paid for it.
Yep.
You can choose when the cheapest price for electricity is and use that to charge your battery. But I just thought of another advantage. IES capacity limits are coming down, inverter energy system capacity limits. So many of the utilities will be saying, 5 kVA maximum single phase.
Right.
And, you try to put in you've got a solar inverter and it's putting out 5 kilowatts and you want to add a battery system with an AC coupled battery that's another 5 kilowatts. They'll say, sorry, you're full.
Right.
But this is a rectifier. This is not a grid interactive inverter. So you've got no capacity limits. You've just a load as far as the network's concerned. So that means you can effectively hide loads without impacting on the grid. And I think
interesting.
This is going to be a thing where customers basically want more self-use power and they're limited by IES capacity. I mean, WA, it's getting terrible, like down to 1.75 kVA.
Really?
In weak parts of the grid. Yep.
So does that mean that if we populate this system out, I don't know, to 32 kilowatts,
you
get 32 kilowatts of STCs as well?
Now, this is probably a good transition to this module.
Okay.
This is where the STCs come in. So there's no STCs on rectiverters because they're not a renewable energy generation device. But this is.
Yep.
So this is your solar module, which you just told me that you doubled the power rating on it.
Yeah, well, originally released as a 1,500 watt solar regulator. And because of some of the requirements for ELVDC, lower than 110 volts for the telco market, we also had a 700 watt version as well. Same thing with firmware adjustments. But then it was determined, reasonably early in the piece that we could actually double the power density, and now we have 3,200 watts.
Wow, this is a 3,200 watt solar charger.
Yeah,
I mean that's whoa. How many amps is that? DC current 60 amps. 60 amps out of this thing.
Times 4 in 1 RU.
Oh my gosh, 240 amps in 1 RU.
Yeah.
That is insane. Now, this is when, like, we're talking about STCs. For those who are not familiar with the acronym, Small-Scale Technology Certificates, part of the Small-Scale Renewable Energy Scheme that's been running since, I don't know, last 15 years or more. And it is winding up to 2030. But STCs kind of match the price of solar panels beautifully at the moment. So they have been for a long time. So really putting in more solar is actually a way of keeping the costs down.
Sure, absolutely. And if you have the footprint available, the more solar, the better.
So we've got 8 of these in the res unit. Let's call it the Delta Power Station.
I do like that.
And that's 24.5 kilowatts of DC power. If we allow for the 1.33 times oversizing, which you allow to for STCs, that's 32 kilowatts of solar panels I could connect to that system.
Potentially.
That's a lot of STCs.
Yeah, potentially with the system out there. And of course, the system could be made to be much larger as well.
And it's got a footprint of like 600 by 600. It's just tiny.
I think that's like me saying I've got a 32-inch waist.
Yeah.
I think it might be, is it 600 or 700?
Oh, yeah, sorry, 700 by 600. But yeah, it's pretty small. I mean, it's the size of your hot water tank, right? Yeah. As you'll see. But that's an amazing amount of energy density. So these solar charge modules give you another advantage over typical AC coupled systems. With AC coupled systems, you've got to match your AC solar inverter to your AC inverter, battery inverter. They've got a one-to-one relationship.
Yeah.
But often you might have an energy demand that's high, but a power demand which is low. Telco's a perfect example, a constant power rating, but a lot of kilowatt hours per day. So when you're doing a design, this is what got me really excited by this, separating these two components out, is you design the rectiverters for the power demand the customer requires and the solar chargers for the energy demand. They're separate units.
Yeah.
You don't have to have one for one anymore.
But then all interacting together in a common backplane, managed by one controller.
Wow. Now, just in terms of the specs of this, it's got a input range of 85 to 420 volts. So that is a little bit lower than your your conventional solar inverters. So your strings are probably going to be more like 8 panels maximum.
Yeah, typically. Yeah.
And this is a 48 volt module, so 48 volt output. And I noticed it has a 25 amp fuse. So that's its maximum input current is 25 amps.
Okay.
Yeah, right. Okay, cool. So these are all numbers that, from a design point of view, you need to consider when sizing a system. Right.
So, and the fact that there's a fuse in there makes it very easy to repair as well. But really for the cost of these units, it's if you've got a red light and it's under warranty, then we just send you another one out.
We'll see this in a minute. The hot swappability is just a game changer. It's not even licensed electrical work.
No.
The customer can do this.
Correct. Yeah, all the dangerous bits are hidden away.
all the dangerous bits are hidden away. So, I mean, let's just be devil's advocate. What would be the limitations of using the Delta Power Station? Are there any limitations?
Well, only that the marketing material now is going to have to be changed to the Delta Power Station. Look, I think that it does come in one big box, as you mentioned.
Yep.
So it's so there is a consideration that you've got to land that box in a particular, in a space. I think that another consideration would be certainly the batteries. The battery types, and you and I talked about this before, we're providing a lithium battery solutions, but there are other lithium batteries out there. So I think that, we need to look at really what we want to achieve out of those batteries as different sort of characteristics. I think that's one area that we can consult with, and there may be some considerations around that because we want to be able to see, how that battery's performing. And some batteries are, although they call them all smart batteries, but some are smarter than others. So we want to get that information from the battery into the controller and then be able to monitor and manage that from an information perspective.
So the smart pack, which is the controller, effectively is a BMS as well.
No, the BMS, lithium batteries have their own BMS. What we're doing here is providing basically voltage or energy for that battery.
All right.
However, what we want to do is you don't want to be going to multiple points to get that information out. So what we do is we do some data point mapping with the BMS on the lithium battery. That's made available back into the controller. And therefore, that same information that we can normally be seen in the BMS is now visible from the controller. So you've got one spot to go and look at what's happening with that power system.
Okay, so voltage set points, charge and discharge set points.
State of health as well.
State of health, temperature.
Temperature, yeah.
All of those things are monitored by the smart pack.
6 or 7 points that are presented and also provide you with historical information as well.
Now, in terms of monitoring, what are your choices for monitoring one of these systems?
So we have, of course, the controller, which is inside the cabinet. You can also have it set up on a network. We also have some functionality where we have an app that resides on your phone. And now the idea behind this app is that you don't have to open up the door of the cabinet. Now that requires a 4G router or a dongle or something like that. But there's multiple. There's also a web browsing function as well. So if you've got the IP address, you can talk a little bit later about how that's addressed in the system, but there's multiple different ways to access the information from the controller.
Yeah, so I really like the look of the display on the SmartPack Touch. It's just great. Like, it's very intuitive. It's got little icons, the symbol for a battery, a symbol for a solar panel, a symbol for an inverter, a rectiverter, etc. So, and when you touch them, bingo, you get more information. So it just kind of guides you into finding out how, the stuff that you need to know without having to navigate deep menus. But then connecting it to my LAN, like you said, I can see it on my laptop in my office. And it's got that extra data port on the front where you can plug a laptop straight in without having to open the cabinet, the internal cabinet anyway, and straight away connect your laptop to it for the same level. I loved all that accessibility. But then you told me, and there's an app.
Well, we'll have to set it up for you, and we'll come to give me a good excuse to come down next time.
Indeed. I think that's what customers want, is something super simple like an app. So, in terms of when I say customers, I'm thinking your residential customers, not your industrial customers. Your industrial customers want to just put it on their network and monitor it through SCADA or whatever.
And look, for the industrial customers or people that perhaps would have a suite of these products around their in their environments, there's also another product which is called Multi-Site, which gives you the ability to bring all of these products together and have a great level of visibility in, as the name suggests, in a multiple site arrangement. And from that point, you can actually set KPIs for each of those sites. Is the solar performing as you first thought? How are the assets actually performing? Particularly if there's a few sites.
Yeah, okay. Now, lastly, I want to talk a bit about the clever thermal management. This cabinet is designed to be freestanding. It doesn't have to be put in the shade.
Oh, ideally be put in the shade.
It would work hard otherwise.
It'll work harder then.
Okay, so just give a little bit of love, right? Just not sitting in the middle of a paddock in full sun.
We have these cabinets in the snow country, the high country, and in the Pilbara.
Right.
So they're pretty hardened that way. You've got a number of different, a couple of options. Certainly there's what we call a heat exchanger or an air conditioning unit, which basically is a closed loop system, so there's no outside air getting
So it can
in.
be at a really dusty mine site and there's never any filters to be clogged with dust.
And that's the benefit of having those types of systems. The disadvantage, of course, is that there is some what we call parasitic load or energy being used to run those two devices. The aircon, of course, being a little more. Although the aircon will deal with very harsh temperatures, the heat exchanger, there will be a rise inside the cabinet. But outside of that too, if you're not in one of those environments, if you're in an environment like here, for example, then a fan filter type arrangement works just as well. In fact, actually works better.
Right, so it's actually exchanging air with the outside atmosphere, but through a filter?
Through a filter.
So there's a little bit of maintenance of that filter over time, depending on the dust. Yeah, but it's quieter and more efficient at cooling.
Yeah, but the controller will tell you when that filter needs to be looked at.
Right, yeah, it looks after you.
Yeah.
I reckon we should go and check it out.
You want to?
Yep.
Okay.
Let's do that.
To the LTEC power station. I'm going to have to write that one down.